Hello, beautiful chemists, and welcome to the AP Chemistry Exam 2025, specifically free response question number 4. Now, free response question number 4 is the first of the short form free responses on the AP Chemistry Exam. It's only worth 4 points, and it's designed to take about 7.5 to 8 minutes of your time. And this one is a little bit more focused than the long ones. It's more focused on intermolecular forces, melting point, boiling point, heat of vaporization, and a quick little question about hybridization thrown in. So it should be fun, so let's get started. Free response question number 4 begins with a diagram of some molecules. And the prompt says, a scientist is investigating the properties of a mixture of CH3OH, that's methanol, and H2CO, that's formaldehyde. The scientist generates the following diagram to represent the mixture, and part A asks us to identify the hybridization of the valence electrons orbitals of this carbon atom in the H2CO molecule. So like one of those or one of those. Okay, so it's probably a quick question. What we want to do is count how many bonding regions it has. 1, 2, and 3. We're going to count that double bond area as a single bonding region because that involves a sigma bond as well as a pi bond. Now, the pi bond doesn't get hybridized. The pi bond is above and below the region of the sigma bond. So we're going to only count the sigma bonds, so the 1, 2, and 3. And to hybridize to make 3 sigma bonds, we're going to have to hybridize an s orbital and 2 p orbitals. And so the quick answer to this question is that it's sp2 hybridization around that carbon in that molecule. So congratulations if you put sp2 for your answer for part A. Then we get to do a little drawing. In the diagram provided, draw a single dashed line to represent a strong hydrogen bonding attraction between one methanol molecule and one formaldehyde molecule in the mixture. So we've got a number of ones to choose from, and we have to think about what constitutes a hydrogen bond or something that can do hydrogen bond. Hydrogen bonding occurs when a hydrogen is attached not to a carbon or other atom, but specifically to an oxygen, a fluorine, or a nitrogen. So because this hydrogen and this hydrogen are both attached to an oxygen, that bond is very, very polar because oxygen is very, very electronegative. And so these two, this one here and this one here, are appropriate for doing some hydrogen bonding. Then where is it going to want to attach to on the other molecule? Well, because this is very electronegative and this hydrogen then is more positive, it's going to want to attract to something that is negative or a negative region of another molecule. And I'm looking at, and I think the most convenient negative region of this molecule over here is this negative oxygen on the other end. So I'm going to go ahead, actually I already did that, and we can draw a dotted line or a dashed line between this hydrogen and this oxygen. Okay, I think that's the most convenient place to do it. So hopefully you put a dashed line between one of those two hydrogens and one of the other oxygens. All right, let's go on to part C. The scientist plans to cool a gaseous mixture of these two molecules to form a liquid mixture and finds data on the two compounds. The data are summarized in the table. So we have melting points, boiling points, and the enthalpies of vaporization for both of those. Propose a temperature to which the mixture should be cooled such that both will be liquids. Okay. So for both of them to be liquids, they have to be below their boiling points, because if they're above their boiling points, they will be vaporizing too much and not be in the liquid state. So I'm looking at these two. This one has the lower boiling point, so I know I'm definitely going to have to get it down to 254 Kelvin or below. But I have to double check. Will any temperature below 254 work for cooling them to be both liquids? No, because if we look over here, we have melting points as well. So if I continue past 254 and get down to 181, then the formaldehyde, the H2CO, will actually turn into a solid and not be in the liquid state. And so I would say that the temperature should be somewhere between 181 and 254. Below 254, they're liquids, but at 181, they start turning into solids. So somewhere in between those two temperatures. And the last prompt for question 4 is, the scientist analyzes the mixture after it's cooled and determines that 8.59 grams of the methanol is present. Calculate the amount of thermal energy in kilojoules that was removed to condense the 8.59 grams of methanol, which has a molar mass of 32.04 at its boiling point. So this is a little bit like a stoichiometry question involving the enthalpy of vaporization. So here's what I got. 8.59 grams of methanol. I'm going to quickly change that into moles, and I get 0.268 moles of methanol. And then, since I know this is in kilojoules per mole, I can take my number of moles and multiply by how many kilojoules it takes to condense an entire mole, and I get 10.1 kilojoules as my energy released that was removed from the methanol in order to condense it. So there you have it, a quick hitting FRQ on intermolecular forces and hybridization. I hope you found this helpful. As always, you can send me some questions in the comments if you have them. And in the meantime, happy studying and have a great day.